Welcome back. So in this brief lecture, we will present an important characteristic about the efficiency of internal combustion engine. In this plot, there seems to be a lot of data. We will slowly unfold what is being presented. Along the x-axis is the rotation per minute. So this is indicative of the speed of the vehicle. What we are trying to present is the efficiency of an 1.9 liters spark ignition engine. Along the x-axis, we have the speed, something indicative of the speed. Then along the y-axis, we have the torque that is provided by the engine. As we saw in the previous lecture, the torque is dependent on many features, especially besides velocity. It also depends upon alpha, which is the angle of incline over which the vehicle is traveling. So if it's steeper, if that slope is steeper, it will require more power to get through that steep slope. So besides speed, it also depends upon the slope of the road over which the vehicle is traveling. Of course, there are other features like the mass and friction factor and so on, drag coefficient and so on. All right. And then there is these curves which are of constant power. So, for example, if you look at this curve, even when you decrease the speed as you go in this direction, your power remains the same because you may be traveling in a in a slope, along a slope. Okay, so what I'm trying to say is that besides velocity, there is also these features which determine the power requirement. So these are curves of constant power. And the last and an important feature, perhaps the most important feature for this plot, is the specific fuel consumption. Kilowatt hour is a measure of energy. So what is being presented is the fuel here, for example, 250 grams per kilowatt hour. So all these numbers indicate the fuel consumption of the engine. So this is of same fuel consumption. This is of same fuel consumption. These are like contour plots. What is important to notice is that if the fuel consumption is low, the efficiency of the engine is high. So as you can see, there is only a narrow region of a particular torque and velocity uh, in terms of RPM, wherein the engine is most efficient. As you move from this narrow region towards this region, and so on, your fuel consumption increases. Therefore, in a way, your efficiency decreases. So even if you are along the same velocity, for example, given by a specific RPM, as the torque increases, you may be able to increase your efficiency or decrease your fuel consumption. But beyond a particular torque, your fuel consumption increases and efficiency decreases. The same thing is true if you have the same power provided. It is also crucially dependent on velocity, as even though the power provided by the engine is the same, as you increase your velocity given in terms of RPM, your fuel consumption decreases and then increases. Therefore, your efficiency first increases and then decreases as the speed is increased. So this particular feature, that there is a narrow window wherein the engine operates most effectively and consumes the least fuel is very, very important. And this motivates us to consider a hybrid vehicle. And in the next lecture, we will present different hybrid vehicle architectures. Thank you.